Miss Polk, can you hear me? Just checking. Okay. So today we are solving quadratics by completing the square. Before we actually get into doing that, we're going to practice factoring some special case trinomials, and then you'll see how that kind of feeds into it. So before we get into today's lesson, technically, I would like for us to do some factoring practice. The first one I'd like to do is f of x equals x squared plus 18x plus 81. When I factor this, I'm looking for two numbers that multiply together to get the third number and add together to get the middle number. What two numbers is it going to be? Anybody?
9 and 9.
9 and 9.
9 and 9. So this is actually what we call a perfect square trinomial, because when I factor it, it factors into the same number twice. So the way I would write this is f of x equals x plus 9 squared. A perfect square trinomial has a square for the first number, a square for the second number, and then, third number, and then the second number is twice whatever the root is going to be. Okay, so my root was 9, that middle number was 18. So we can use this information to factor these special cases a little bit faster. So the second example we're going to do is x squared minus 16x plus 64. I know this is a perfect square trinomial, so my factor is going to be the same number twice. 8 times 8 gives me 64, so I know that my number is going to be 8. X times x gives me x squared, and then it's always the sign of my middle number. So this factors into x minus 8 squared. Does that kind of make sense? Maybe, hopefully. Is anybody confused by that? So knowing that it's a perfect square trinomial, the numbers that make up my factor are going to be whatever the root is of my first term and whatever the root is of my third term with the sign of my second term. So this one was x minus 8, this one was x plus 9. Using that information, let's go ahead and factor this one. This one is most definitely not as pretty as the first two, but I can use some patterns that occur in the first two to factor this one quite easily. I want you to look specifically at our factors in our middle terms. What relationship do we see happening? Anybody?
3 can go into 9 and 4 can go into 64.
Okay, that's not, yes, 3 and 4 can go into those. But I'm asking, can we use this relationship we've already seen to factor this one without having to do the mathematical work? So what do I notice between 9 and 18 here? What is 9?
Half of 18.
Half of 18. What is 8 compared to 16?
Half of 16.
It's half of 16. So this is, if it's a perfect square trinomial, it's always going to factor into whatever half of my middle term is. Because with fractions, we don't actually want to have to do the work if we don't have to. So I know, since this is a perfect square trinomial, it's going to factor into x plus whatever half of that middle term is. Since it's a fraction, we can just multiply it by 1/2. And we get 3/8. So this factors into x plus 3/8 squared. I know this is right because if I square 3, I get 9. If I square 8, I get 64. So it does work out. So if it is a perfect square trinomial, we have a shortcut for factoring it. This comes in handy for this next portion that we're going to do. On these next problems, I would like to find the value c that makes it a perfect square trinomial. So on this first one, I have x squared plus 14x plus c. I know this is a perfect square trinomial, so I need to find what the c value is. This c value is always going to be whatever half of my middle term was squared. So c here would equal my middle term 14 divided by 2, and then squaring that answer. 14 divided by 2 is 7, and 7 squared is 49. So to make this a perfect square trinomial, I take my middle term, split it in half, and square the answer. For the next example, because we're going to do 2 more of these, I'm still trying to find c that makes this a perfect square trinomial. This time I have a squared plus 12a plus c. My c, remember, is my middle term split in half and then squared. Half of 12 is 6. 6 squared is 36. So we are finding the value c that makes this a perfect square trinomial. That way I could factor it really easily. For example, without doing any work at all, I know that this factors into x plus 6 squared. And this first one that we did factors into x plus 7 squared. I didn't have to do any work at all because I knew it was a perfect square trinomial. We have one more example. This time, I have m squared plus 11m plus c. My goal, remember, is to find the c that makes this a perfect square trinomial. So just like before, we're going to take that middle term 11 and split it in half and square our answer. Well, I can't reduce 11 over 2, so I'm just going to have to square it the way it is. So I square the 11. 11 times 11 is 121, and 2 times 2 is 4. So my c value here would be 121 over 4. Because this is a perfect square trinomial, I know that it would factor into x plus half of that second term, so 11 halves squared. The next thing I'd like to practice before we get into actually completing the square is solving for x from a factored perfect square trinomial. So on these next problems, we're going to solve for x. So I want to use factoring in order to solve. So I have x squared plus 6x plus 9, which I know is a perfect square trinomial. So it's going to factor into x plus 6 divided by 2 is 3, and then set equal to 36. My goal is to get x by itself, so I'm gonna have to square root both sides. A square and a square root cancel each other out, so I'm just left with the x plus 3 on the left. When I take the square root, I have to account for its positive and negative versions. So when I take the square root of 36, it's plus and minus the square root of 36. The good news for us is that the square root of 36 is 6. So I get positive negative 6 on the right-hand side. My goal, remember, is to solve for x, so I need to get the x by itself. To do that, I'm going to subtract the 3 over. So I end up with negative 3 plus and minus 6. And then I have to split that into two problems, 1 plus and 1 minus. So negative 3 plus 6 equals 3. And negative 3 minus 6 is negative 9. So then my two solutions, which I will put in curly brackets, are negative 9 and 3. So when we use factoring to solve this, or technically it's called the square root property, but same thing. We turned it into its square root, perfect square trinomial factor, so x plus 3 squared. Then I square rooted to get rid of the square, and then I isolated the x. So it's kind of just a different order than we've done it before. Let's go ahead and do another one. Using the same property, I would like to solve for x in x squared minus 10x plus 25 equals 27. I know that left-hand side is the perfect square trinomial, so it's going to factor beautifully into x minus 5 squared, still set equal to 27. My goal is to isolate the x, so I need to square root both sides. I'm left with x minus 5 equals positive and negative square root of 27. I don't know what the square root of 27 is right now because it's not a perfect square, so I'm going to leave it as the square root of 27. And I'm going to go ahead and add the 5 over. And I end up with x equals 5 plus or minus the square root of 27. You can leave it as plus or minus, but it still has to go in your curly brackets because those are our two solutions. Okay, so what we're going to do now is we're going to put all of this together and we're going to solve a quadratic by completing the square. Okay, so we've done each of these different skills for a reason because completing the square involves all of them in some way. Okay, so when we're completing the square, I'm going to go ahead and write out the steps. These steps are written out fully in the notes. I might give like the abbreviated version of them. So step 1, when we are solving by completing the square, before we do this, remember all of our quadratics are written as ax squared plus bx plus c. Okay, so that's important. Our first step is to divide everything by a. My goal is to not have a number in front of the x squared, so we want nothing but a 1 in front of that. To make that happen, I have to divide everything by a on both sides of the equal sign. Step 2 is to isolate the constant term. So that number that doesn't have a variable attached, we're going to move over to the other side of the equal sign. Then we will find our new c, just like we did in the examples up there, to create a perfect square trinomial. Step 4 is to balance the equation. So whatever I do to the left side, I have to do to the right side as well. Step 5 is to rewrite the left side as a squared binomial. Step 6, square root both sides of the equal sign. And then step 7 is to solve for x, or whatever our variable is. So I know this is a lot of steps and it might seem overwhelming, but when we get into it, it's really not that bad. I'll give you guys a second to finish writing these, and then we will move into actually doing some problems. And I will tell you, a lot of you probably won't like this to begin with, but the more you do it, the easier it gets. So these are all going to be examples of solving by completing the square, okay? The first example is going to be x squared minus 14x plus 19 equals 0. Following the steps that we already listed, the first thing I need to do is divide everything by the number in front of x squared. Here there is no number there, so it's already a 1, so I don't need to do that step. Step 2 was to isolate the constant term. So I'm going to take this 19 and I'm going to subtract it over to the other side of the equal sign. Step 3 is to find the new c term that's going to turn the left-hand side into a perfect square trinomial. Just like we did before, to find that c, I'm going to take my x term, which is negative 14. I'm going to divide it by 2, and I'm going to square my answer. So negative 14 divided by 2 is negative 7. Squared is 49. Okay, so now the left side is x squared minus 14x plus 49 equals negative 19. But step 4 is to balance our equation. So because we added this third number to the left-hand side, we also have to add it to the right-hand side. Okay, that's how we balance our equation. So whatever we add on one side, we have to add to the other side. Step 5 is to write the left side as a binomial squared. I know I can do that because this is a perfect square trinomial. So just like on the first problems that we did, this is going to factor into x minus 7 times x minus 7, which I can just write as x minus 7 squared equals negative 19 plus 49 is 30. And now this is just like that last set of examples that we did. We're going to solve for x. First thing I'm going to do is square root both sides. I get x minus 7 equals the positive and negative version of the square root of 30. And then step 7 says to solve for x. So I'm going to add that 7 over, and I get 7 plus or minus the square root of 30. Put those in curly brackets and you are done because I cannot reduce that anymore. Questions, concerns, or issues after that first example? Let's do another one. I hope you all are actually listening and not just, I don't know, having your cameras on. I'm sure you are, but. This time I have v squared plus 18 equals 9v. Before I can start my completing the square process, I need to have everything on the left-hand side. So I need to subtract that 9v over. So I have v squared minus 9v plus 18 equals 0. Step 1, divide everything by the number in front of your squared term. Good for me, there is nothing there, so I assume it's already a 1, so I can skip that one. Next, I move the constant over. When I move it over, it takes the opposite sign, so it's now a minus 18 on that right-hand side. I left a space, so I can go ahead and complete the perfect square trinomial on the left-hand side. So I need to find my c value. As before, my c value is half of that middle term, so negative 9 divided by 2 and then squared. I can't really reduce negative 9, so it's going to have to stay, or except negative 9 over 2, so it's going to have to stay a fraction. But I can still square it the same. Negative 9 squared is 81. 2 squared is 4. So my c value is 81 over 4. What I do to one side, I also have to do to the other side. So I'm adding that 81 over 4 on both sides. My next step then is to factor this left-hand side using that shorthand that we figured out for the perfect square trinomial. This is going to factor then into v and half of whatever that middle term was. So my middle term was 9, half of 9 is 9 over 2, and it takes the sign of that middle term. So v minus 9 over 2 squared. You're good, David. I will be putting this lesson, this recording up on Canvas. Also, the notes already there. We're in the examples part of it. So I factored the left-hand side using my perfect square trinomial shorthand that we learned. On the right-hand side, I need to put those numbers together, but I can't put them together the way they are right now. So I'm going to have to turn that negative 18 into a fraction over 4 so I can combine it with the 81 over 4 that's already there. In order to do that, I simply multiply that negative 18 by 4. When I do that, I get that it's negative 72 over 4 plus 81 over 4. So I just took negative 18, multiplied it by 4 to get the negative 72. And then it's over 4 because that's what I multiplied by. I can add those two together. And when I do that, I go ahead and I get 9 over 4. So now my problem is reading v minus 9 halves squared equals 9 over 4. And I'm going to solve for v. So I need to square root both sides first. When I square root the left-hand side, the square goes away. When I square root the right-hand side, I need to see if I can reduce if I can. 9 and 4 are both perfect squares. So when I take their square roots, I just end up with the square root of 9, which is 3, over the square root of 4, which is 2. So I have v minus 9 halves equal positive negative 3 halves. And then I'm going to add the 9 halves over. So I get v equals 9 halves plus and minus 3 halves. Just like before, I split it into two problems, one addition and one subtraction. So v equals 9 halves plus 3 halves gives me 12 halves, which is 6. And then v equals 9 halves minus 3 halves. 9 minus 3 is 6 over 2, which is 3. So my two solutions are 6 and 3. Questions, concerns, or issues? How did I get negative 72 over 4? I took this negative 18 right here, and I multiplied it by 4 and then put it over the 4 denominator that I required. So negative 18 times 4 is negative 72, and then 4 was the denominator I was desiring. Okay, so let's do another one. Next example, I'm going to skip C and go to D, if you're looking at the notes. So I have 2D squared minus 10D plus 5 equals 0. Everything's on the left-hand side, so I don't have to worry about moving anything. Step 1 says that if there's a number in front of my squared term, I have to divide everything by that number. So I'm going to divide everything by 2. When I do that, I'm left with D squared minus 5D plus 5 halves equals 0, because I can't reduce 5 halves. Please do not write it as a decimal. Step 2, I need to move that constant over. So I get D squared minus 5D equals a negative 5 halves. I left a space so that I can complete the square and make this a perfect square trinomial on the left-hand side. That perfect square trinomial, third term C, remember, is my middle term split in half and then squared. So C is going to be equal to negative 5 over 2 squared, which means I'm squaring the top number and the bottom number, which leaves me with 25 over 4. So I'm adding the number 25 over 4 on the left-hand side to make a perfect square trinomial. What I do to one side, I also have to do to the other side. This allows me to factor the left-hand side quite easily because it is a perfect square trinomial. So it's going to factor into whatever my variable is plus half of my middle term. So my middle term here is negative 5. So half of it is negative 5 halves. So this factors into D minus 5 halves squared, because it's D minus 5 halves times D minus 5 halves. And then I need to combine my two fractions on the right-hand side. I can't do that currently because 1's over 2 and 1's over 4. So I need to take negative 5 halves. I need to multiply it by 2 over 2. When I do that, I get negative 10 over 4, which I can then combine with the 25 over 4 that's already there. When I do that, negative 10 plus 25 is 15. So that gives me the result of 15 over 4. So now I have D minus 5 halves squared equals 15 over 4. I would now like to solve for the D. So to do that, I need to square root both sides. Square root and a square cancel each other out. So I have D minus 5 halves equals positive negative square root of 15 over 4. I would like to point out that I don't have to take the square root of a fraction as a whole. I can individually take the square root of the numerator and the denominator, which sometimes allows me to do a little bit more simplification. I cannot take the square root of 15, so it's going to stay under the radical, but I can take the square root of 4, which is 2. So now that 2 is not under the square root anymore because I was able to take the root of 4. So I have D minus 5 halves equals plus and minus the square root of 15 over 2. To solve for D, I need to add that 5 halves over. So I get 5 halves plus or minus the square root of 15 over 2. Both of these fractions are over 2, so I can simplify it a little bit more by writing it all as one fraction. So I'm going to put the numerators together and then put them over their common denominator. So this is what you would put in curly brackets. D is equal to 5 plus and minus the square root of 15 all over 2. Questions, concerns, or issues with that one? Okie dokie, let's do another one. my next example is going to be x squared plus 10x minus 11 equals 0. Everything's on the left-hand side, so I can go ahead and get started. There's nothing in front of my x squared, so I don't have to divide anything out. So my first move is to actually move the 11 over. Which then allows me to complete the square on the left-hand side. So my goal is to make this a perfect square trinomial. To do that, I need to add in this third term here. This term that I add in is our C term now, and it is my middle term split in half and then squared. My middle term was 10, so when I split it in half, I get 5, and when I square 5, it becomes 25. So the third term that creates my perfect square trinomial here is 25. What I do to one side of the equation, I also have to do to the other. Now that I have a perfect square trinomial on the left-hand side, it's going to factor into my root of x squared, which is x, and my root of 25, which is 5, with the sign of my middle term. You can also think about it as half of whatever my middle term is. So half of 10 is 5. And then it's squared because it's actually x plus 5 times x plus 5. My right-hand side, I can just add together. 11 and 25 is 36. Now my goal is to solve for x. So I'm going to square root both sides. When I do, I get x plus 5 is equal to positive and negative square root of 36. Square root of 36 comes out beautifully into 6. So this is x plus 5 equals positive and negative 6. I subtract the 5 over. So I get negative 5 plus or minus 6, which allows me to split it into my two problems, one addition and one subtraction, to give me my two answers. So I have x equals negative 5 plus 6, which equals 1, and x equals negative 5 minus 6, which is negative 11. And those will go in your curly brackets. Questions, concerns, or issues? Okay, I think we're going to do one more example, and then I will turn you loose to look at your homework. Your homework is 10 problems and encompasses all of this. So the last example we're going to do is one of my favorites. So I have x squared plus 8x plus 22 equals 0. My first step is to check to see if there's anything in front of my x squared. There isn't, so I can move on to just moving the constant over to the right-hand side, which leaves me with x squared plus 8x equals a negative 22. Then I can complete the square. I go to the left-hand side, and to get this number right here, I take half of my middle term, and then I square it. Okay, so 8 divided by 2 is actually just 4, and 4 squared is 16. So my left-hand side now looks like x squared plus 8x plus 16. My right-hand side is negative 22 plus 16. Remember, I had to keep the equation in balance, so whatever I did to my left, I also had to do to my right. I can simplify that right-hand side. Negative 22 plus 16 is a negative 6. I can also factor my left-hand side now. So this is a perfect square trinomial. That factors into x plus 4 times x plus 4, which I can just leave as x plus 4 squared. Remember, this second term in my binomial is half of whatever the middle term is in my trinomial, okay? So half of 8 is 4, so that's how we get that. And then equals negative 6. My goal now is to solve for x, so I need to square root both sides. And I get x plus 4 equals plus and minus the square root of negative 6. Uh-oh. I have a negative under my square root. Is that possible? hopefully you all recognize that yes, it is completely possible because we have learned complex numbers, which allow us to take something that seems impossible, like the square root of a negative, and turn it into something I can actually compute with. So in order to get rid of that negative, because that's the only way that I can figure this out is if I temporarily remove it, is to put an I out front. So this turns into x plus 4 plus or minus I times the square root of 6. Now I can work with this because this is positive and it seems like something that could actually exist. So now my next step is just to subtract the 4 over. And I get x equals negative 4 plus or minus I times the square root of 6. And you would put that in curly brackets, and then we are done. There are 2 on your homework that will have an I in them, I believe. Questions, concerns, or issues? If you need more examples, there are some more that we skipped over that are in the notes. I just wanted to maybe give you a couple minutes to look at your homework before class is over. Okay? Any major questions, concerns, or issues right now? Okay, well then your homework is on Canvas. Please go ahead and start working on it. And let me know if you have any issues at all. I will stay on the call for the remainder of the class period. Okay?
Homework's due Monday, right?
Homework is due Monday, yes.